Section 1.3 is about frequencies, frequency tables, one way to display data, and how you can use them. So, rounding guidelines when you're doing this is to carry one more decimal place than was present in the original data, and then round at your final answer only. So if your data gives you one decimal place after, you're going to carry 2 until the very end and then round back down to 1. If it gives you none, then you carry 1 if it goes past that. So that's usually how you'll work unless it specifies. Try not to do too much rounding until the very end. That way your answers are more precise. Fractions are fine unless it tells you not to use fractions. You don't have to turn it into decimals unless you really, really want to. So you'll notice when I go through, a lot of times I'll keep it as fractions, and that's fine. So we're going to start by talking about levels of measurement. So with our qualitative and quantitative data, there's different levels of that measurement. So your qualitative, or your qualities, categories, you have nominal and ordinal. So nominal measurement is just the names of data. There's not an order that necessarily matters. So you're just naming things. Colors. Like there might be, that's kind of where you have those jersey numbers I talked about a little bit in the last section. You know, your soccer players, they might have numbers on their jerseys, but that number doesn't necessarily mean anything. It's just the number they got. Ordinal is still that qualitative, but there's a way to put it in order. So first, second, third in a race, that order matters. Whether you first is different than second, you know what that order means, but you can't necessarily measure the difference between those places. So you know in a race, first came in before second, but you don't know how much before second. You don't know if it was 3 seconds or 3 minutes. So order matters in that ordinal sense, but you don't know the difference between the orders other than one is more important or before the other. Then we get into our numerical or our quantitative data. We have interval and ratio. Interval is where you can measure a difference. There's no starting point and negatives are okay. Data can be compared by amount. Ratio starts at 0 and can be compared using division. The biggest difference is ratio has no negatives. So I like to think about it in interval is like temperature. Think about Maine winters. You can go negative temperature, but ratio is more like rain. You can't get negative rain. It doesn't go back up into the sky. You can get no rain or no snow, but you can't get 0 rain. So interval can be negative. Ratio cannot be negative. That's how I remember the difference between those two. All right. Then we get into our tables. Frequency is the number of times a value occurs, and relative frequency is your ratio. That's the fraction or the proportion of times. So frequency is just the amount. Relative frequency is that percent or proportion. And then cumulative is you're going to add or accumulate everything below from what's been going on. So let's build a table. So a table is any kind of data put into a table like this. This is called a cell, that one piece. So we're going to build. A distribution is another way to say a display of data. So we're going to turn this set of data, this group of numbers, into a frequency table, a relative frequency table, and then a cumulative relative frequency table. So we start with a bunch of data. This is just a list of numbers, a bunch of data. And then here we've organized them by data values. So there's 2s, 3s, 4s, 5s, 6s, and 7s. All of those numbers show up in this data. Frequency is the amount of times it shows up. So 2 happens 1, 2, 3 times. So the frequency is 3. 3 shows up 1, 2, 3, 4, 5 times. So the frequency is 5. 4 shows up 1, 2, 3 times. 5 shows up 1, 2, 3, 4, 5, 6 times. 6 shows up 1, 2 times. And 7 shows up once. So that's our frequency distribution, or our frequency table. We just list the amount of times. Now if I add those all up, I get a total of 8, 9, 10, 11, 17, 18, 20. Let me double check. 1, 2, 3, 4, 5, 6, 7, 8, 9, 15, 16, 18, 19, 20. Good. So there's our frequency. Relative frequency is the proportion, the fraction, the ratio of the total. So 2 would be 3 out of 20, 5 out of 20, 3 out of 20, 6 out of 20, 2 out of 20, 1 out of 20. So we could do those as fractions, or we can turn those into decimals. So 3 divided by 20 is 0.15. 5 divided by 20 is 0.25. 6 divided by 20 is 0.3. I'm just going to add the 0 so they're the same. 2 divided by 20, 0.1. 1 divided by 20, 0.05. So there's your relative frequency. That's just the percent or the proportion. Now, cumulative relative frequency is you accumulate. So you start with the first one. So our first one is 0.15. Then we add those up as we go down. So we would add the 2 and the 3 together. So 0.15 plus 0.25 is 0.40. You can hear my dog in the background, maybe. Sorry about that. Stop barking. People are allowed to walk by. Stop. Shadow. Stop. The neighbor kid's out riding his bike. Shadow. Enough. Okay. Then we're going to add the 4 to that. So add 0.15. Nope. 0.4 plus 0.15 is 0.55. Then you add the next one. You get 0.85. So you're just accumulating, adding them up as you go. Add 0.10, you get 0.95. Add 0.05, you get 1. So by the time you get to the top, hopefully, it should add up to 100%. So frequency table is all of your amounts. Relative frequency is your percent. Cumulative just adds them up as you go. All of the ones before. All right. Example 1. Use the table to find the percentage of heights that are less than, and then it gives us a bunch of questions. So let's go fill out our table, then we'll come back and answer the questions. So notice down here, our table has ranges, 59.95 to 61.95, and then 61.95 to 63.95. So it gives us the data with the frequency and the relative frequencies. Now we should fill in the cumulative relative frequencies. So the first one is always that first value, 0.05. And then we would add the 0.03 to get 0.08. And then we'd add 0.15, so we get 0.23. Add the 0.4, so we get 0.63. Add 0.17. Add 0.12. Add 0.07. And add 0.01. So now we have our cumulative relative frequencies. Now we can use this to answer the questions. So the percentage of heights that are less than 65.95. So here's 65.95. So the percent less than that would be all of these percents. So we could add those up by hand, or we can just use this cumulative number and get 0.23. So I'm just going to write that up here, 0.23. Now let's look at question B. The percent of heights that are between 61.95 and 65.95. So that's these two rows. So we would add these two percents, 0.03 and 0.15, which would give us 0.18. Now we go to the next one. Percentage of heights from 67 to 71. So 67 to 71. So that's these two rows. So 0.17 plus 0.12 is 0.29. Good. So we do the next one. 67 to 73. So that's going to add one more to that. So 17, 12, and 7. 17, 12, and 7 would be 29 plus 7 is 36. Okay. Now, erase these so I don't get confused. More than 65. So we're going to start at 65 and go up. So that's everything above here. So 40 plus 17 plus 12 plus 7 plus 1. 40, 17, 12, and 7 and 1, and we get 77. So we're just using this table to answer questions. It's the benefit of it. Once you have the data, you can do anything with it. The number of players who are between 61 and 71. So start at 61, end at 71. So we're going to add these ones. So that's 3 plus 15 plus 40 plus 17 plus 12. 3, 15, 40, 17, 12. You get 87 this time. All right. Now it says, what kind of data are the heights? So they're numbers. So we're going with quantitative. And there's all kinds of decimal points. It's height, so it's measurement. So that means it's continuous. If we think about the levels back before with heights, you can't go negative. You can't be a negative height. So it's also going to be a ratio level if you wanted to go that far. It didn't specify. Now let's answer the next question. Describe how you could gather this data so that the characteristics are of all semi-professional soccer players. So you could do simple random, and like you have all of the numbers, like all of the players in there, and you use a random number generator to pick all of them. You could do like 3 from each team. That would be stratified. You could randomly pick 3 teams and ask everybody. That would be a cluster sample. That's a bunch of different ways. So you could pick one of those sample types and figure out a way to do it. All right. Okay, so this one says you try. So fill in the cumulative frequencies, answer A, B, C, and D, pause the video, and then come back when you're ready. All right, so cumulatives. You start with that, add 12 to 14, Add 30, so you'd get 56. Add 16, so you'd get 72. Add 18, so you'd get 90. Add 10, so you'd get 1. The percentage of rain that is less than 9. So 9 is here, so it'd be everything up to that, which would give us 56. And then the next one is the percent of rain between 6.99 and 1305. So we'd add these 3. So 0.30 plus 0.16 plus 0.18 gives us 0.64. All right. Then we have 2.95 to 9.01, which is those first 3. So because it's the first 3, we can use our cumulative, or we can just add them up. So we get 0.56. Then the last question is between 11.03 and 13.05, which is just that one block, one row. So we don't have to add anything. So it's just 0.18. So there we go. 0.18, 13.05. There we go. All right. And then here, example 2. 19 people were asked how many miles to the nearest mile they commute to work each day. The data is as follows. Then it gives us a list. Complete the table. So let's fill it in. If you want to try it on your own, pause the video. If you think you need help, go ahead and do it. It's up to you. So let's see. So we have a 2 here. I'm going to make tick marks. 2, 5, 7, 3, 2, 10, 18, 15, 20, 7, 10, 18, 5, 12, 13, 12, 4, 5, and 10. All right, so then I'm going to turn those tick marks into frequencies. 2, 1, 1, 3, 2, 3, 2, 1, 1, 2, 1. Add those up. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, which is what I was supposed to get, so that's good. So our relative frequency would be 2 out of 19, 1 out of 19, 1 out of 19, so on and so forth. 2 out of 19, 3 out of 19. So if I left those as fractions, that would be my relative frequency for each one. And then the cumulative would be 2 out of 19. Add the numerators. So 2 plus 1 is 3 out of 19. 3 plus 1 is 4 out of 19. 4 plus 3 is 7 out of 19. 7 plus 2 is 9 out of 19. 9 plus 3 is 12. 12 plus 2 is 14. 14 plus 1 is 15. 15 plus 1 is 16. 16 plus 2 is 18. 18 plus 1 is 19. So 19 out of 19. So that's how you would do it with your fractions. If you turned them into decimals, we can round. So decide if we're going to do 2 decimal places. So 0.1, oops, I added an extra 0 there. 0.11. And then 1 out of 19 would be 0.05. So if I added that, 11 plus 5 is 16. And then this would be another 0.5. So 16 plus 5 would be 21. And then 3 out of 19 would be 0.16. 21 plus 16 would be 37. We said 2 was 11, so 37, 48. 3 was 16, 48 plus 16 is 64. 2 was 11, so 64, 75. 1 was 5, so 80. 1 was 5, so 85. 2 was 11, so 96. And plus 5 is 1.01. Now, this goes over 1. That's okay, where there's a lot of rounding in here, so we're pretty close. Now, if we'd gotten like 1.5, obviously that's way off, but we're that close because we're rounding. That's okay. So fractions, decimals, it's up to you. That is 1.3 with your frequency tables.